Welcome to Business Analytics, Chapter 1, Introduction to Data Analytics and Decision Making. Introduction, slide 1 of 3. Living in the age of technology has implications for everyone entering the business world. Technology makes it possible to collect huge amounts of data. Technology has given people the power to be responsibilities to analyze data and make decision making. Large amount of data exists already and will increase in the future. One of the hottest topics in today's business world is business analytics, and also called data analytics. These terms encompass all of the types of analysis discussed in this book. Business analytics typically implies the analysis of very large data sets. For this reason, the term big data has also become popular. By using quantitative methods to uncover the information in these data sets and then acting on information, again, guided by the quantitative analysis, companies are able to gain competitive advantage. The goal of this book is to teach you how to use a variety of quantitative methods to analyze data and make decisions in a very hands-on way. This book combines two topics from two separate fields: statistics and management science. Statistics is the study of data analysis. Management science is the study of modeling, building, optimizing, and decision making. Three important themes run throughout this book. Data analysis includes the data description, data inference, and search for relationships in data. Decision making includes optimization techniques for problems with no uncertainty, decisions analysis for problems with uncertainty, and structured sensitivity. Dealing with uncertainty includes measuring uncertainty and modeling uncertainty explicitly. The figure below shows the themes of the three books and the sub-themes of how they are and which chapters they go into. The software included in this is we're going to use Microsoft Excel. Excel, as we've learned, is the most powerful spreadsheet. There's a file that we're going to play with. So these are some of the different things we're going to be looking at. Analysis Tool Pack has tools for data analysis, including correlation, regression, and inference. Solver add-in uses powerful algorithms to perform spreadsheet optimizations, and Solver table add-in shows the optimal solution changes when certain inputs are applied. Palisade's Decision Tool Suite, at risk, can run multiple replications of the spreadsheet simultaneously, perform a sensitivity analysis, and generate random numbers from variable probabilities. Risk Optimizer combines optimization. Big picture, smart drawings, add-in used to represent the elements and relationships in the model so that you can better visualize the problem. Palisade's Decision Tool, Stats Tool, generates statistical output quickly in an easily interpreted measure. Precision Tree used to analysis data. Uncertainty, the primary method for performing this type of analysis. Decision Tree. Other programs in Decision Tool Suite: neural tools mimic the working of the human brain to find neural networks that quantify complex nonlinear relations. Top Rank, a what-if add-in used for sensitive analysis to see what inputs have the largest effect on a given output. Evolver, although we will not use it in this book, Evolver provides an alternative to Excel Builder Solver. DADM Tools Add-in. Palisade software may not be available in your place of employment. Albright developed an add-in called DADM_tools that implement decision trees and simulation, as well as forecasting the several basic analysis tools. This add-in is freely available from the author's website and is free. Introduction to Spreadsheet Modeling. A common theme in this book is spreadsheet modeling, where the essential elements of business problems are entered and related to Excel spreadsheets and further analysis. The goal of this section is to get you up to speed using effectively the rest of the book. Most spreadsheet models involve inputs, decision variables, and outputs. The input have given fixed values, at least for the purpose of the model. The decision variables are those decision-making controls. The outputs are the unlimited ultimate value of interest. They are determined by the input and the decision variable. Spreadsheet modeling, the process of entering the inputs and decision variables into spreadsheet and then related them appropriately by means of formula to obtain outputs. After this, you may perform a sensitivity analysis, maximize or minimize a particular output, create charts to show how certain parameters are related. Example 1.1, ordering NCAA t-shirts. Objective, to build a spreadsheet model in a series of stages, with all stages being correct, but each stage being more readable and flexible than the previous stage. Solution, the formulas allow for the order quantitative to be less than, equal to, or greater than demand. If demand is greater than the order quantity, Randy will sell all t-shirts ordered for 18. If the demand is less, Randy will sell as many as he can, and then at 18 and price all leftovers at 6. If function. Excel's if function is as if condition. Result if true and result is false. The condition is this. The two expressions, if true and if false, can be expressed. Expressions you would enter in a cell, number, text, or other, including the if functions. Spreadsheet layout and document. Think carefully about your spreadsheet layout and the document you work carefully. For layout, consider whether certain data are best oriented rows or columns, whether your work is better placed in a single sheet or in multiple sheets. For documentation, use descriptive labels and headings, color coding, cell comments, text boxes to make your spreadsheet more readable. So it's going to look like this. And as you can see, we have a basic spreadsheet over here, and it allows us to have what we're looking at. It takes some time to lay it out. When we think about this up front, it makes more sense. In the following example, a company wants to project its cost of producing products given that the material and labor costs are likely to increase. We build a simple model, then use Excel's charting capabilities to obtain a graphical image. Objective, to learn good spreadsheet practice to create copyable formulas with the careful use of relative and absolute address, and to create line charts and multiple charts. Solution, the completed spreadsheet model appears in figure 1.7 in the following slide. So as you can see, we have the chart going up from 400 to 460,000 or whatever the case may be, but this is how it looks. Simple chart. Here's our data points, and it allows us to see what's happening on how much it's going to cost. Some steps: input, design, output, project unit cost of wood, project unit labors, and project that in the chart. Many businesses problems require you to find the appropriate level of some activity. This might be the level that maximizes profits or minimizes costs, or it might be the level that allows the company to break even, non-profit, non-loss. The following example illustrated a typical break-even analysis. Objective, to learn how to work with a range of names, to learn how to answer questions, what-if questions with the one-way data tables, introduction to Excel's GoalSeek tool, and learn how to document and audit Excel models with the cell comment and Excel's formula auditing. Solution, The completed spreadsheet model appears in Figure 1, the following, and so on. So here's what the data looks like that we're able to do what we need. Creating a range. To create a range name for a field, which could be a single file, highlight the cells, click Name box, and just in the left of the formula bar, type the range. Alternatively, if a column or row of labels appear next to the cell, it can be a range name. You can use these labels as a range name. Pasting range names. Including a list of range names in your spreadsheet is useful documentation. To do this, select cells such as G2 in Figure 1.9, select using the formula drop-down list, the formula ribbons, and then click Paste List option. You get a list of range names that you can select from. Inserting cell comments. Inserting comments in the cell is a great way to document non-obvious aspects of the spreadsheet model. To enter a comment in a cell, right-click the cell, insert comment, and type your comment. This creates a little red mark indicating that the comment, you'll be able to see comment by moving the cursor over it. Enter formulas with range names. To enter a formula that contains a range name, you do not have to type the full range name. You actually have to have two options. First, you can click or drag the cell and range names will appear in your formula. Second, you can start typing the range name in the formula, and after a few letters, Excel will show you a list. Forming a one-way data table. Data tables are also called what-if tables. This lets you see what happens to select output as the selected inputs range. The power of data tables. Unfortunately, many Excel users are unaware of the data tables, which are among the most powerful and useful tools in Excel. After you have developed the model that relates the inputs to outputs, you can then build data tables in a matter of seconds to see how the outputs range. Data tables are perfect for answering large numbers and what-if questions. Using a goal seek. The purpose of the goal seek tool is to solve one equation is unknown. It is used here to find the response rate that makes profit equal to 0. Specifically, goal seeks allow you to vary a single input and force the single output value. To use it, select the goal seek from the what-if analysis drop-down list in the table and fill it out in the resulting box. Using a formula auditing tool. You can use this handy Excel tool to see how all parts of this are related. The formula auditing tool is available in the formula ribbon. Ordering the quantity, discount, and demand uncertainty. If the following example we again attempt to find the appropriate level of some activity. How much of the product to order when customers demand the product of uncertain. Two important features of this example are the presence of quantity, discount, and explicit use for probabilities in the model uncertainty. Objective: to learn how to build in complex logic if formulas. To get help with the about Excel functions, to learn how to use lookup functions, to see how two-way data provides answers to more extensive what-if. Solution to profit model figures 1.7 of the following data. This is what it looks like. VLOOKUP. This is a useful tool. First, create a vertical lookup table. These values use the comparison listed in the left column of the table, the corresponding output values in as many columns to the right as you like. The VLOOKUP function takes 3 to 4 arguments. 1, the value you want to compare. 2, the range that you want. 3, the index column that you want, from where the index of the left column is 1 and the index is 2, and so on. And 4, true, the appropriate match. False, for an exact match. If you omit the last statement, the values in the left column of the table are entered in ascending order. Two-way table. Data table. A two-way data table allows you to see how a single output cell varies as you vary two inputs. Unlike one-way data table, only a single output cell can be used. To create this table, enter the reference to the output cell to the top left corner of the table. Enter possible values of the two inputs below and the right of the corner. Then select the data table from the What If analysis drop down on the data ribbon and enter the reference to the cells where the original two input variables live. Sum product functions take two range arguments, which must be exactly the same size and shape, and it sums the products of the corresponding values in these two ranges. This is an extremely useful function, especially when the range involves a large scale. Estimating the relationship between price and demand. The following example illustrates the very important modeling concept, estimating relationships between the curve fitting. The idea can be illustrated at a relatively low level by taking advantage of some useful Excel tools. Objective: to illustrate the Excel trend line tool and illustrate conditional formatting. This example is divided into two parts, estimating the relationship between price and demand and creating the profit model. Both can be found in the file graph demand. Estimated relationship between demand. Here's a scatter plot of demand versus price. We consider three possibilities. The best fit curve power model, maximizing profit, sensitivity to variable cost. How does the best price change as a unit variable cost change? Create a chart of maximum profit or best price versus unit cost. The maximum profit decreases at a decreasing rate. The unit cost increases. In many situations, cash flows are received at a different point in time, and the company must determine a course of action for this. The discount factor is 1 divided plus the discount rate. The discount of cash flow that occurs per year for now, multiply it by that. The net present value is the sum of the discounted cash flow. Decisions involving time and value. Money earned in the future is less valuable than money earned today, for the simple reason that money earned today can be invested to earn interest. Similarly, costs incurred in the future are less costly than incurred today. This is why you typically don't simply sum up revenues and costs over a multi-period model. You instead discount future revenue and cost for fair comparison with revenues and costs incurred today. The resulting sum of the discount cash flow and the net present value, and in the form of the cornerstone of much financial theory application. Calculating net present value at Acorn. To illustrate the efficiency, selection, and copying a large data set, learn that. Solution to model Acorn the flows in figure 1.29. So here's their data as we have it. Net present value takes two arguments, the discount rate, enter as a decimal such as 0.075 or 7.5%, and stream cash flows. These cash flows are assumed to occur in consecutive years starting at the year one. If there is an initial cash flow at the beginning of the year one, such as an initial investment, should be entered outside the net present value function. Deciding whether to continue with a drug. Net present value calculations are typically used to see whether a certain project should be undertaken. If the NPV is positive, the project is worth pursuing. If the NPV is negative, you should look for other places to invest money. That is the end of Chapter 1.